Now let us see valence bond theory. The metal atom or ions under the influence of ligand can use its n-1d, ns, np or ns, np, nd orbitals for hybridization to yield a set of equivalent orbitals of definite geometry such as octahedral, tetrahedral, square planar and so on. These hybridized orbitals are allowed to overlap with ligand orbitals that can donate electron pair for bonding. Now you can see a table with number of orbitals and the type of hybridizations. In the diamagnetic octahedral complex CO NH3 whole 6 3 positive, cobalt ion is in +3 oxidation state and has electronic configuration 3d6 4s0. Orbitals of CO3 plus ions are shown in 3d6 ns0 and nd0. Now we can see d2sp3 hybridized orbital of CO3 plus with 6 hybrid orbitals of d2sp3. Now CO NH3 whole 6 3 positive inner orbital or low spin complex. Here 6 pair of electrons from 6 NH3 molecules are shown. The paramagnetic octahedral complex CO F6 3 negative uses outer orbital 4d in hybridization sp3d2. You can see orbitals of CO3 plus ions with 3d6 4s0 4p0 configuration. Now sp3d2 hybridized orbitals of CO3 plus with 6 hybrid orbitals of sp3d2. In COF6 3 negative outer orbital or high spin complex, you can see 3d6 and 6 orbitals with 6 pair of electrons from 6 F- ions. In tetrahedral complexes, 1s and 3p orbitals are hybridized to form 4 equivalent orbitals oriented tetrahedrally. For NiCl4 2 negative, here nickel is in +2 oxidation state and ions has electronic configuration 3d8. You can see orbital of Ni3 plus in 3d8 4s0 and 4p0 configuration. sp3 hybridized orbital of Ni2 plus with 3d8 configuration and 4 hybrid orbitals of sp3, and NiCl4 2 negative high spin complex with 3d8 configuration and 4 pair of electrons in 4Cl minus. Each Cl minus ion donates a pair of electrons. The compound is paramagnetic since it contains 2 unpaired electrons. Similarly, NiCO whole 4 is tetrahedral geometry but is diamagnetic since nickel is in 0 oxidation state and contains no unpaired electrons. In the square planar complexes, the hybridization involved is dsp2. For NiCN whole 4 2 negative, nickel is in +2 oxidation state and has electronic configuration 3d8. You can see orbitals of Ni2 plus ions with 3d8 4s0 and 4p0 configuration. dsp2 hybridized orbital of Ni2 plus having 4 hybridized orbital of dsp2. Now NiCN whole 4 2 negative low spin complex is shown with 3d8 configuration and 4 pair of electrons from 4Cn minus groups. Now we will see limitations of valence bond theory. First, it involves a number of assumptions. Second, it does not give quantitative interpretation of magnetic data. Third, it does not explain the color exhibited by coordination compound. Fourth, it does not give quantitative interpretation of thermodynamics or kinetic stability of coordination compounds. Fifth, it does not make exact prediction regarding the tetrahedral and square planar structure of 4 coordinate complexes. Sixth, it does not distinguish between weak and strong ligands.